Hi and welcome back to the second video of EdMasters for the series Basic Concepts of Organic Chemistry. In the first video, I asked you two questions and they were why negative charge has maximum electron donating tendency, and second, which is the strongest acid and why. Now I will give you answer to the first one, and that is negative charge is the extra charge on an atom. Therefore, it is not under the influence of nuclear charge, while lone pair is, hence not that easy to be given. And the second question, we will discuss about it when we will study chemical properties of acids. Basically, in this video, we are going to discuss the physical properties of acids. So there are mainly 4 physical properties, but before we go on to discuss about this, what actually is a physical property? A property that is measurable and can be observed, like color, hardness, smell. So all these come under the physical properties. So how acids look, tastes, behaves, that we are going to discuss in this video. First physical property is that they are sour to taste. So there are certain naturally occurring acids that can be found in apples, grapes, and lemons. So these are malic acid, tartaric acid, and citric acid. So when you yourself will taste them, you will experience the sourness on your tongue. So, but please don't taste HCl for experiment. So the second physical property of acid is that the acid solutions turn blue litmus solution red. Now the question arises that what is a litmus solution? Litmus solution is a kind of an indicator. Indicators, as the name suggests, are those which helps to indicate. So if I read out, an indicator is a substance that undergoes a distinct observable change when conditions in its solution changes. This could be a color change, precipitate formation, bubble formation, temperature change, or other measurable quality. There is a type of indicator, and that is pH indicator. A pH indicator changes color over a narrow range of pH values in solution. There are many different pH indicators which display different colors and act between certain pH limits. So a classic example is litmus paper or litmus solution. You can see in the photo that there is a blue litmus paper which changes its color to red. When it is put in a solution, that means that solution is acidic. You can use these litmus papers to check acidic level of your products at home. Examples, soap, shampoo. It will be really interesting to know how much is the basic level or how much is the acidic level. I mentioned that litmus solution is the type of pH indicator. But how is litmus solution formed? The actual color of litmus solution is purple, which is extracted from lichen, a plant belonging to the division Thalophata. And this is commonly used as an indicator. There is not only lichen from which indicators can be formed, but there are many other natural materials like red cabbage leaves, turmeric, colored petals of some flowers, which indicates that there is some acid or a base in a solution. So when litmus solution is neither acidic nor basic, its color is purple, as I mentioned, and these are called acid-base indicators, or sometimes they're also referred as indicators. Here there are 3 pictures. First, lichen plant, second, petunia flower, and third, hydrangea flower. So these can be used to make litmus solution, and this is how they look. The color of the flower depends on the pH of the soil. Here is a pink color, while it might change and it can be turned into blue depending on the pH, and pH of the soil keep on changing. In the fourth picture, you can see 3 colors. One is red, purple, and blue. So the original color of the litmus solution is purple. When there is acid, it turns into red, and when there is a base, it turns into blue. Third physical property of acid is acid have a pH value less than 7. Now, to understand this, first let us see what is pH. It was actually invented in 1909 by Danish biochemist S.P. Sorensen. It is measure of acidity or alkalinity of water-soluble substances. So what is the full form of pH? pH stands for potential of hydrogen. In other words, it measures acidity or basicity, or how much acidic or basic a solution is. Here you can see pH scale. So a pH value is a number from 1 to 14, as you can see, with 7 as the middle, that is the neutral point, and the values below 7 indicates acidity, which increases as the number decreases, 1 being the most acidic value, while the values above 7 indicates alkalinity, which increases as the number increases. So 14 being the most alkaline or basic. This scale, however, is not a linear scale, like a centimeter in scale, you can say, in which two adjacent values have the same difference. It is logarithm scale in which two adjacent values increase or decrease by a factor of 10. For example, a pH of 3 is 10 times more acidic than a pH of 4 and 100 times more acidic than a pH of 5. Similarly, a pH of 9 is 10 times more alkaline than a pH of 8 and 100 times more alkaline than a pH of 7. These two photographs shows different colors of acidic and basic solution. Lemon juice is acidic, hence its color is red, while bleach is basic, its color is yellow. As the basicity increases, color becomes darker in the scheme of blue, while same goes for acid in the scheme of red. The last physical property of acid is odor and texture. They have a strong smell. You must have experienced that if someone opens an acid bottle at one end of the laboratory and you are standing at the other end, you still can smell it. And they are very sticky to touch. Few examples are hydrochloric acid and acetic acid. Acetic acid also, though it's a weak acid, but still it has a strong smell. Thank you for watching this video. I'm Avni, and if you want to take personal classes for chemistry or science, please join EdMasters. EdMasters is a holistic website. For more information, click the link given below, and don't forget to like, share and comment. Thank you and see you soon.